Hello guys, welcome back. So in this video we are going to understand the another question of weekly contest 455, and I have already uploaded the Q1, right? Question number 1. This is question number 2. So if you have not watched Q1, please go and watch the question 1 and then understand the question 2 that we have given here. Okay, so let's pause this video and go through here the statement. Okay, the question is saying that let me zoom out a little bit so you will understand the example. Zoom out first. So what the question is saying that we have given inverse coin change, right? Means you have given one index based integer array that is called nums, where nums at I represent the number of ways to select total I using an infinite supply of some fixed coin denominations. So each denomination is a positive integer with the value at most nums dot length. So what is denomination, right? So we are talking about this denomination. What is denomination, right? So denomination is a value of coin or bill, right? So a denomination is a kind of value of coin, right, or bill, you can say. So in programming or math problem like coin change, something that the problem is related, right? So if the questions comes like, so denominations are a specific value of coin which is available for you, right? So how we are understanding the, let's imagine you have some coin, right? Let's suppose I have a coin of 1 rupees, right? You have coin of 2 rupees, 3 rupees, like this you have given, right? 4 and 5, right? Like this we have given the coins. So these coin denominations means, let's suppose I'll talk about 1, 2, 3, 4 and 5. So if these are the 5 coins, right? So we can, if you write the denomination, means coin denominations are 1, 2, 3, 4 and 5. Means each have some value, right? Or you can say bill, right? So that is the coin denominations. Okay, so in this problem you are not given the denomination directly, right? Instead of, you are told that using some hidden denominations there are nums of ways, right? We have given, right? There are some nums of ways, means we have not given directly, it is given, the denomination has been hidden, right? So we have given in which manner, means nums ways, right? Nums ways at I. So nums ways at I to make the amount what I, right, we have. So our task is to figure out what those hidden denominations were, right? And so let's consider if the nums ways we have given like this, right? Like this. Okay, so the output become what? 2, 4, 6. How? Let's understand. So if we'll represent the number of ways like this, right? Let's suppose 1, 2, 3, 4 we have, right? So when 1 is 0, amount is 1, right? So number of ways is 0, means there is no way to select coin with the total value 1, right? Then it is saying 2 is 1, so the only way is 2, right? They is saying 3, amount 3 is 0, there is no way to select the coin 3. What does it mean? Let's suppose I'm talking about if we have 1, 1, 2, 2 and 3. Very simple step. Okay, if you have the coin denominations, right, number of ways, so you can say the number of ways, right? Num ways, you can say. If it is given like this, right? So what does it mean? This 1 means to make 0, right? This 1 means to make 1, right? Like that we have to make, right? So if this is 1, so the one way to make 0, this is the one way to make 1, this is the 2 way to make 2, right? This is the 2 way to make 3, this is the 3 way to make 4. So what is this? These are the index I, right? So these num ways we have given, num ways represent the number of ways to select the total amount. So what is the total amount we'll select? So we'll select, right, if we'll select the ways one way, so we'll make 0 amount we will make. If we'll make the num ways to make is 1, so what we will make? We'll make 1. Like this we will make. You understand? Means if you try to reverse engineering, right? So just try to reverse engineering this denomination, right? If you'll do this denomination reverse engineering, what you will find? this will you find the possible. So this is numSpace. So you will convert the possible denominations is what, like this, right? So if you will make the possible denominations become what, 1 and 2 are the possible denominations. If you see, 1 at 1 is 1, 2 at 2 is 2, but rest of the thing, if you see, it is different, right? Means if you will take the 1 rupees along, it gives 1 ways, right? If you will take this value 1, it means if you will take the 1 rupees along, it will give you what, 1 ways to make every number, right? If you will take this 2 rupees, that adds more combination, like what, here it will, we can say 1 plus 1 is 2, right? We can say 2. So these are the possible combination that we can say, like the rupees can add the more combinations, understand? Or we can say another, we can say what, 1 plus 2, right? We can also say, means the possible combination that can happen with respect to this is what, with respect to this one is 1 plus 1, then it become what, 2, and then it can become 1 plus 2. So these are the possible combination with respect to this possible denominations, right? So denominations is a value of coin that you can use, like 1 2 3 5, right? Like that we have, right? And we have given number of ways to make each amount, right? And our goal is to find the denomination coins value, right? We have to find the coins value and that cause the cause those values, right? Understand? So let's think, let's suppose once more, right? What we have given, let's suppose we have coins of denominations, like we can say 1 or 2, just think 2 we have given. So this is nothing but your coins, right? If 1 and 2 we have given coins, this means you have infinite coins of value 1 and 2, right? You have infinite coins of value, that is 1 and 2, understand? So if we'll say that if you have the amount and how many ways to make, right? So this is the ways to make it, and this is your count, right? So if you will write the amount 0, so this is your base case, right? So take nothing, we cannot do anything, just take, this is your base case. So you cannot take anything, nothing you will take, right? Nothing you will take, right? But count is what, 1. When you will take 1, right? When you will take 1, what you will select, ways you will select 1, means count is still is 1, right? When you take 2, amount 2, it means what, either you will take 1 plus 1 or you will take 2. How many ways you will take? Either you will take 2 rupees, right, of coin 2 or of coin 1, or you will can take coin of 1 rupees, right? That you can take. So the total count is what, 2. If we'll talk about, if you want to make 3, the possible combination that you can make coin of 1 rupees 3 times, you will do plus, or you can take 1 plus 2. So the possible combination is what, here 2. So we can write 2. When we'll say we want to make a amount 4, right? So the possible combination will go 1 plus 1 plus 1 plus 1. So 4 times we'll take 1, then we'll take 1 plus 1 plus 2, right? And another we can take what, 2 plus 2, right? Like that we can take. So the total combination will go what, how many are these 3? So we can 3. So this way we can compute how many ways we can make amount from 0 to 4, right? Understand? It is very easy, just you have to understand the inverse coin change, right? So if we'll talk about give me 1 second. So if we'll talk about what, the numSpace, right? Now understand the numSpace. What will become the numSpace? So nums will become this count, right? This will be your count. So we'll say nums, it will become 1 1 2 2 and 3. This is your numSpace, right? You can say that, right? This is your numSpace we have given. So at each I, we can say number of ways to make I using coin 1 and 2, right? And we have these things, right? We have given this. So now if you will reverse this problem, you have to figure out which coin value denomination would have been used, that exactly challenge in this problem, right? So this problem is saying to reverse this problem, inverse this problem, you can say, right? Means we have given this and we have to find the things like this. Okay, means you have to figure out which coin values for these denominations would have been used here, right? So this is the exactly challenge that we have to do in this inverse problem. Okay, let's suppose what I'm trying to say, give me 1 second, let me clear this. Okay, so let's just think that we have some amount is there, what we have 1 0 1 2 3 and 4. So these are the amounts we have given, right? So if you start from the base, you will get what, 1 0 0 0 0. Then we can say we add the coin 1. When you will add the coin, you will get 1 1 1 1 1, right? When you will add the coin 2, what you will get, 1 1 2 2 3, right? So the final numWays is what? It will become what? 1 1 2 2 and 3. So this will be your numWays. Understand? Means for each coin, add the combination to the multiple amounts, and so the coin 1 will add to every, since every amount can use once repeatedly, right? So if you'll talk about 1 2 3 4, each one is required this way. Similarly, if we'll talk about the 2, we can say coin 2 adds more combinations in the 2 3 and 4, right? So in this we can add this, right? So the combination for the combination 1 and 2, right? These were our denominations, right? Denominations, right? So numWays is to make you can say numWays to make the nums at I, right? It is the number of ways to select total amount I, right? And so our task is to guess denomination from the numWays. We have to guess, right? We have to guess the denomination from this nums of base. Okay, so our intention to this problem, because this problem is a reverse of the classic coin change problem, right? Normally you are given coin denominations and you want to compute the number of ways to make every amount, right? So here you have to do very simple thing that you are given the number of ways to make each amount, right? And you have to figure out the coin denomination that could be caused, right? And so we do what, we'll start with the empty set of coins, and for each index I, we'll check if the coin set can be produce the required number of ways to make amount I plus 1. If not, we'll make the coin I plus 1 itself, and we'll say it is the required denominations. So we'll try adding it each time. If it still doesn't match, then the nums at I, we will know it's impossible to make, and we'll return minus not minus 1, we'll return empty 1, right? So let's go step by step, and then we'll do try run. Okay, so let's understand the approach, how we are going to do that. So okay, so very first what we need to do, we'll start with the empty set of coins, right? And we'll go through each amount from 1 to n, right? And we'll ask, can I make this amount using my current set of the coin? If yes, great move, right? If not, maybe the coin with the value was missing all along, and so we'll try adding it to your set. After adding to the new coin, we'll recalculate, can you make the amount exactly as described in the numset ways? If yes, awesome, keep the coin. If no, it means switch off it, right? And something is off, right? Just switch off that. The given list is invalid, and so we'll return empty, will not do anything. Then what we will do, we'll continue until you have walked through all the amount. Okay, it means what the problem was saying, that you are given a list of numWays where each nums tells you how many different ways there are to make a certain amount of money, right? But the twist was that you are not told which coins value denominations were used to create the list, right? And so our job is to figure out which coins value must have been used, means we have to guess it, right? So how do we think about this problem, right? So we know how the coin change problem works. If you are given some coins like 1 2 5, right, and the total amount says 5, so you can calculate how many ways to make the amount, right? You know that now flipping this problem. Let's suppose you already have the answer, number of ways to make each amount, right? But you don't know the coin values, right? So we have to work backward. Understand? Either you will go the understanding way, or either you will go the flipping way, right? So you can do by all this way. So let's understand the first of way. So first we will do we will use the map, right? So we'll create you can say class variable as a map, because we are going to use the memoization dp calls, because you need to go backward conditions, right? So what you need to do, you first write the recursive dp, right, approach, and you have to count the number of ways to form the amount using the set, right? And you know what are the things you have given. Set we have given, index given, amount we have given, right? So number of ways, what we will do in the very first step, we will consider if amount is equal to 0, that we have seen. This is your base condition. So one base to make 0 is to take nothing, will not take anything here, right? If the index is equal to 0, it means if only one coin in the set, right, then we will check its divisibility, right? And if it is like this, right, then it means either you pass 1 or 0, right? So let's suppose let's come down, then you will understand. Okay, let's suppose the function that we have given, right, the main function we have given, numWays, right? So if we'll consider the numWays, this one, the example one, right? So if this is numWays we have given, means we need to find the coin denominations, right? So to find the coin denomination that generate this exact sequence of number of ways to make amount 1 to 10, right, from 0 index to 9, right? So we will provide the logic. How we are going to add the logic? It means we have to set the you can say logic, right? How we are going to set the logic? It means we'll say this set contains nothing but, you can write like what, the set contains nothing, like this, means no coins yet, right, in this. Okay, means this set doesn't contain anything, right? So when we'll iterate, right, when I equal to 0, let's suppose, right, in that case the index is what, we have the index, right? So you will suppose that current coin set is empty, there is no coin. So this time we'll try computing the ways to make amount 1 to since the coin set is empty, right? So number of ways is what, 0, right? So nums at 0, if we'll do, what is coming, it's coming 0, so it will match 0, right? Means let's suppose what I'm trying to say, if I will say here, let's suppose that we are going to take amount 1, right? So ways we have given what in this case is 0, right? And what we want to do, just think, when index is 0, right, in that case we want amount equal to 1, right? We want amount equal to 1, right? Ways is equal to 0, correct? And we want to find the nums at ways 0, right? So nums at ways is 0, right? So it matches the value, right? So we don't need to add anything. We'll say this value set is nothing but the set having the value is empty. We don't need to add anything, any coins in this one. Next time when the index become not equal to 0, it become 1 equal to 1, right? In that case we have to find it, we have to check the set is equal to 2 or not, right? So it should become what, nums at ways is nothing but your it become what, 1, right? In that case the, you can say we have to add the value to here, right? Understand? So because if you observe this, right, nums of ways we have given like this, right? And so when it was 0, we are adding nothing but 0, empty. But if it is amount is 1, we will add we'll try 2 value set, right? The 2, because See how many ways we can make 2 using 2, right? There is only one way, right? Either you will use 1, right, or either you will take 1 2 will take, or either you will take 1 2 times, right? So number of ways to make nums at 1 is 1, but we'll keep these 2 because 1 is, we can make 2 also 1 plus 1, right? So we'll use nums at ways like this. You know the nums at when amount is 3, how we can do that, right? So like that we will do that. Then first of all we'll check if this is already in the map, we'll return from the map. If it is not in the map, we'll return directly. Okay, we'll calculate it, sorry. So try taking the coin, right? How we are going to take that? We have to find the nums base amount this, you have to pass this function, you will return, you will pick the data here, right? It means the very first step means we will take a base case where amount equal to 0, will return 1. If the amount is 0, it means you have found a valid combination, count base 1, right? If the case is 2, if index is equal to 0, it means if there is only one coin left to use, index equal to 0, then we will check if the amount is divisible by that coin or not, right? So if the amount is divisible by the coin, that coin, it means yes, right? Either yes or not, right? So we, when it is divisible, right? So we can make it using the coin that will return 1, okay? And if it will not divisible by that coin, it means there is no way, and that then we will return what? 0. Very simple, okay? Then to you can say avoid the repetition calculation, we'll do the memorization cache. You know, the if the calculation is already done, we do not need to calculate again. You just get from the memorization memory, or you can say cache, right? So what we will do, so this memorization concept will avoid the recalculations, right? Calculations. And so if we have already computed the number of ways to make this amount with the index, will return the cache result. How will return the cache result? Just return map.get key, you will return the key, mean it is already calculated. Understand? Then what we should do, we'll choose to skip or we'll try to take the coins, right? Either you skip or you take the coins, right? Means choose or skip, right? So first step 3 we'll choose, and step 4 we'll skip it, right? So if we want to, if we can use a coin that is called set.get index, right? It means we can use this coin, right? When you get set.get index at this, means we will get some coin, right? And then we'll try using it, and we'll subtract it from the amount, and then we'll try, right? What we will try, we'll pass here number of ways, and you will get pick or not pick, right? So not pick you will get here, right? How? Number of ways you will pass the set index -1, and this is your amount, right? You will pass, means either you will pick it, you will choose it, then when you will choose it, you will do this code. If you are skipping that, you are not picking this, means you don't want to pick it, you want to skip this coin, then you will try this previous coin, will move to index -1, right? Because we are skipping it, then we will take what, we will skip this coin and we'll try with the previous coin, means we have to move to the index -1. Understand? Then what we will do in the next step, we'll save the data and we'll return it, right? It means we save the result in the cache, first of all, memory map, right? And then you return pick or not pick. Okay, so you will pick or not pick through this method. So this will give you the number of ways, right? So you can count the number of ways to form amount and set, right? You can form it. Okay, now let's get back to the find coin method, right? Okay, this is our main method, right? So this method is nothing but your find coin method, where you are passing these nums of ways, right? These ways. It means this is our core logic. Means you are given nums at some value, right? Nums at value will get some value is there, right? Means num set ways is, this is 0 1 2 something is there, right? Means these are the element that is called how many ways we can make amount I plus 1, because this is not 0 index, this is 1 index. You remember problem statement, right? It is saying 1 index integer num set, right? So that we'll write what we'll say that the nums at I and nums ways at I is a element. It means it says how many ways to make amount I plus 1, right? And so you will figure out how the coins denomination works in this method. Okay, so let's start with empty coin set, right? So this will be our answer because the return type is list of integers. So you will take our answer in the set form and you will return it, right? So we will try building the correct coin set here, right? How we are going to do? So from I to length, you know the length, right? Nums ways dot length, we will traverse for all these elements from 0 to the last element, 5 element, right? Fifth element, the last element is 5, right? From 0 to the last we'll traverse, and for that we'll write what for loop. We'll traverse this loop, means we want to go through each amount one by one, right? So that we can get what we can get how many ways can I make I plus 1 using the coin set, right? That we have given here. Okay, so the first step is to do what we will do, compute the current number of ways to make I plus 1, right? And that way we will do this. Now what we should do, we have to find the number of ways, right? It means how many ways can I make I plus 1 using the coin set, that is I plus 1, right? And to do that you will call the nums ways, right? And you will pass size minus 1 and I plus 1, right? You will start from here, right? Either you go the forward or backward, right? So you have to choose the way, and according to you have to update that logic. So if you have already have some coin, right, you can try computing how many ways can I form, right? I plus 1, right? So does it match what expected, right? To find that, you will just check that is it expected or not. So nums at I equal to ways, it is expected, means we will continue. If the number of ways matches, means we will not do anything, do nothing, just continue it. Then we'll do what in the next step. What we should do, we will say if it is not, right, it means maybe we are missing a coin of value I plus 1, right? So we'll add this, we'll try adding that coin and we'll recheck, right? So again we'll check for I plus 1, this is the new ways. We will recompute, you can say recompute the updated set using the same thing, right? You just pass the same thing that you are sending here, you just try this one, you can recompute the new ways, right? Still if it is not matching, right, if still doesn't match, right, it means right, you are trying to find the new ways, right? And if it still doesn't match, means input is invalid, right? Means even you are adding the new coins, if we can't form the expected number of ways, means there is no valid solution, and will so return is as a empty list, you can say, right? If this is not the case, we'll return our final coin set. Okay, I hope you have understood this problem statement and the coding, right? If still you have any doubt, guys, let me know in the comment section that you have understood or not. And if you understood, please make a time complexity and space complexity in very short line of statement, and if it is good, I will give you heart, and the other people will understand this is the time complexity and space complexity with this program. Okay, thank you guys, thank you for watching this video. I'll see you in the next one.